Welcome 103 students. Couple shorter end videos today. Today on the first here we'll wrap up our local scale winds and then we'll work our way, as I said, into a primer on stability. Real fast, a little bit of a post-mortem on the weather event that we talked about in class on Wednesday. I won't go as far as to say this turned into what meteorologists would refer to as a bust forecast. But it's definitely not at the extreme end of things that was being anticipated when we met on Wednesday morning. You can see here the storm reports. These will likely increase as we move throughout the day on Thursday and even into Friday as folks get out from National Weather Service offices and do surveys and the like. But you can see these red triangles showing a swath of tornadoes, generally from south central Mississippi into central Alabama. Actually a nice little complex in southwestern Missouri with a squall line. A couple isolated events back to the west, but in some ways not a whole lot in areas of northern and central Mississippi. Some wind reports, and definitely not as much as things moved eastward throughout the day. So again, this is generally a good thing. I'm not trying to make it sound like it's a bad thing that not many tornadoes happened, but this definitely had the makings of a much more intense event than what actually materialized. So let's go ahead and let me put this into presentation mode and let's wrap up our local scale winds. Really still working on what's known as the mesoscale here. And we worked our way through the Katabatics and into the Chinook and Fun type winds. And so we're going to kind of conclude this section with the Santa Ana winds. And you may have heard of Santa Ana winds if you've watched some news broadcasts over the years. And that's primarily because they have been a catalyst or something that exacerbates existing forest fires, especially in Southern California. And so you can see here, this is an interesting wind in the sense that it blows from the east or northeast, kind of from southern Nevada and even Utah and Arizona, and comes down the terrain into Southern California, areas near LA and San Diego. And just like we talked about with the Chinook winds, this air coming down terrain compresses and warms. And so this ends up being a hot and incredibly dry wind. And it can reach speeds that are very, very strong depending on the pressure gradient and how this wind behaves. And so you can see here we use the term dries out vegetation. It basically serves as a desiccant, just really can zap any type of moisture from what's available near the ground level. And so this can either again set the stage for fires or make them worse, and even on top of that spread them rapidly by 60, 70, even 80 mile an hour winds that will occur in some of the areas where funneling can occur. So definitely a dangerous wind. And so again, these are just some examples of the forest fires on the side there, the smoke blowing well out into the Pacific Ocean here because of the strength of these Santa Ana winds. A couple other small scale winds. What you see in the lower left, a haboob is a type of a dust storm that probably looks like something out of a Hollywood movie. And it is pretty dramatic. These are real things, especially in the Southwest. There was actually a pretty nasty dust storm earlier this week in El Paso, Texas. And so we're not really going to find dust storms and sandstorms here in Northwest Indiana, but they are found throughout certain parts of the United States, particularly the Southwest and into maybe as far as the Texas Panhandle. Again, much more common in other parts of the world, such as the Middle East. And these are going to be fueled by, again, thunderstorms that'll break down and just an outrush of cold wind that'll help to stir up the dust. And these can be obviously not good for your health. And on top of that, it creates some whiteout, or I should say whiteout. So basically zero visibility conditions. What you can see on the right is not a tornado. It is a dust devil. So if you've ever been on a hot summer day driving down the interstate and seen some swirls happening out in the fields and wonder what was going on, basically intense heating can fuel a small scale circulation. I wouldn't recommend going for a jog into one of these, but in reality they're also not particularly dangerous. The winds in them are not particularly strong, but they can be quite the sight to see if you get in the right region. But again, driven in large part by simply hot temperatures near the ground. And so let's transition here into small scale winds. When we talk about small scale winds, we're really looking at interactions that are occurring down at the surface based upon the frictional layer as well as turbulent motions, things that are going to occur either because of maybe some building orientations or thermally, simply kind of the same mechanism that fueled the dust devil on the last slide. You'll get some upward motion where there's intense near surface heating. And so what's the big deal, or what are some of the results that we get from these small scale winds? We'll talk a little bit about erosion, some sand ripples. If you've ever had a chance to go up to the Indiana Dunes, for instance, and you'll see some ripples in some of the sandy areas up there. And then if you've ever seen some interesting features in snow as well, we'll talk about those very briefly. This is going to be a pretty chill section here. And then a little bit about what we can do to kind of, well, in some ways actually create some of these turbulent motions, but also to protect other things such as, say, interstates from getting impacted by snow. So the idea there are the snow fences. We'll talk a little bit about that. And so we've worked our way again from the synoptic scale the other day and all the way to the mesoscale, and now we're really getting down to these micro scale features. And so one term that will come up occasionally here as well as in some future sections of the class is this idea of a planetary boundary layer. And so what we're talking about here is the boundary between Earth's surface and the free atmosphere. It's pretty small. Think of it as about a mile deep, which, well, is kind of large, but also, now that we know a little bit about Earth's atmosphere, is a very small component. And in reality, we're going to focus on the boundary layer where we get the most intense surface heating, where we're going to effectively feel the results of Earth's friction. So as you get higher and higher up in the atmosphere, and yes, the boundary layer is going to ebb and flow depending on location. It can be deep or shallow depending on the time of day. And so we're going to really look at the planetary boundary layer as this layer near Earth's surface in which a lot of interesting phenomena occur that are driven at least partially due to friction. And then a little bit about what is turbulence. Turbulence is probably really what you think of when I say turbulence. It's chaotic motions, things that are moving in different directions or at different speeds in a relatively small area. So think of, again, you go for a trip over to Target and you see swirly leaves and garbage bags in the corner. In some ways, you're witnessing turbulence. It's not just what happens if things go and feel like a roller coaster when you're on an aircraft, though that is also turbulence. And so the idea of friction, again, friction is really slowing things down at the surface. We've already talked about this when we worked our way through force balances. And so you can see in this example, in fact, let me just go ahead and get up a couple of the tabs here. The idea that if you have some rougher terrain, it's going to help to mix things downward a little bit. And so in this example, you could see winds are stronger as you move from right to left on the x-axis. This is simply elevation above Earth's surface. And so if the wind's calm, you oftentimes are going to have stronger winds that are aloft because we can basically separate our low-level planetary boundary layer from this free atmosphere. If winds are stronger, you help to mix things downward, and that can either occur, again, due to stronger winds. I mentioned up here in this upper box, rougher terrain, and so this may occur if you're in a mountainous region or even just an area with a lot of hills. Unstable air. I know, again, I keep using terms related to stability, and that's what the second video will be about today. Unstable air is just going to be warm air that's rising, and so we can start to mix things in the atmosphere. And this is in some ways related to how we've talked about how this red curve may be how things are in the morning hours, and this brown line more how they are in the afternoon. Stronger winds and greater mixing. And so friction is also playing some role in this behavior. And so what you can see here is a sand dune, and this is kind of an interesting graphic. And so what's happening here is the wind would be blowing from left to right in this image and kind of hitting a point where it slows it down and just has this little bit of a break associated. And these would form over a period of time. You can also see ripples that are occurring here to tell you a little bit about the wind direction that would be flowing, again, in general from left to right across this dune. And so in this image, you can see a number of dunes out here in this, generally speaking, at least localized flat area. There are some mountains obviously off in the distance. And so what we can do is look at a number of these features like sand dunes and snow rollers, as we'll show soon, and learn a little bit about what the wind behavior might be in a certain area. And so if you're in a desert location, these dunes do ebb and flow. The ones that if you do go up to Indiana Dunes National Park are going to have some bearing based upon the fact that you have a generally northwesterly flow. If you were to take all the wind in this area and aggregate it over a year or years of time, yes, you're going to get every wind direction at some point, but you're going to get more times a wind that's flowing out of the northwest. Here you can see a snow roller. These are going to be natural occurrences where we get heavier snow that compacts easy. So think of the stuff that made good snowmen or snowballs when you were younger. And so here we simply have just a little bit of terrain, and we can start to see if there's enough wind, these areas compact. And so, I mean, I guess you have to take it on faith that somebody didn't create this for the purpose of a textbook. Maybe they did. But the point being is that these can actually occur naturally. There's pictures of these that occur basically every year, especially in areas, say, Minnesota, Iowa, areas where there's a little bit of open terrain. You can oftentimes find this a little easier because we're going to need some of those windy conditions to cause these snow rollers to start. We can also look at the flow around objects, buildings, tree lines, towers, skyscrapers in Chicagoland. And so this is complex, and in reality, it's more or less in this to help you understand why you may experience strange wind behavior when you're around a number of objects. As the text says, this can be pretty complex, and it has significant bearing on where any number of things are designed, whether or not we're going to put wind turbines that are designed to generate energy in certain areas of terrain, whether or not for any of you that are in the business school, when you walk down to Urschel Hall and you look on the northwest side of the parking lot and see a weather tower, there's a reason our weather tower is located there on campus. The idea that we want to keep it away from buildings so we don't get any of these eddies or undesirable wind gusts that happen in the lee of terrain. In reality, it's not even ideal. It's still closer to Warenberg than we would like it to be, but you work with what you got. And so wind speed, here you can see the morning hours. Again, things are calm. Our boundary layer is calm. And so we're going to see relatively weak flow. As it goes over this building, it's going to get a little bit of swirly behavior. This is, again, what you're seeing as I keep using the leaf tornado in the corner of your favorite store to go shop at. Afternoons, the flow gets much stronger. It's still getting forced upward over this building, and we can start to get these larger turbulent eddies that occur. If the wind's in a different direction and you got multiple buildings, it can funnel and make it seem like stronger winds. This is, again, what I've referred to when I've talked about Chicago sometimes seeming windy. If you're downtown and between large buildings, that air has to go somewhere. And so it can speed up as it's channeled through a more narrow cavity. Going back to snow, which almost sounds nice right now as I look out my window on Thursday afternoon with wind and 38 degrees and rain. Here what you have is basically the idea of how these snow fences are working. The idea is behind the fence you're going to slow down the wind. This fence that's being designed here is acting as a natural barrier for the wind. And so as it slows down, so as the wind gets slowed down by the fence, it can allow our snow to pile up over time. And so the idea here is that the wind would be blowing again from left to right. Slowly but surely this would keep this snow here from getting out to the right side of the image. If you've ever gone down I-65 towards Indianapolis, especially in wintertime, you'll notice if you look on the west side of the road a whole lot of snow fences. And this is to keep some of that blowing snow, because it can be pretty windy in those open fields, from going over I-65. It can be a pretty nasty area to drive during a winter storm, and these are designed to at least help things a little bit. And so as we get close to the end of this series, the idea that we can also see mountains act as a barrier for wind and cause these wave-type activities. And so this is going to become a little important when we talk about things such as stability, but this is something that's important if you fly on an airplane, which you may have not done now in quite a while, but presumably will again someday. If we get these types of mountain waves, again, the air getting forced upward over the mountain, it may be stable up here. I got that little blue box, and we're going to talk about stability here in the next series. The idea that this air then sinks back downward. But you may start to form some waves, and you can get these swirly air motions that occur as the wind is changing direction in the vertical. And so these rotors or mountain waves can actually be very dangerous for aircraft. These are going to be situations that are monitored pretty closely by aviation meteorologists, and if there is going to be a mountain wave scenario, generally speaking, aircraft will try to avoid this type of interaction because it can be very dangerous, especially if you're down here and potentially near this area of terrain. And so we conclude this series of slides on local winds by this local winds of the world table. I will be blunt. You do not need to memorize anything at all on this. That would be not a good use of your time as the next midterm approaches. But you can see a number of different winds there. Some have kind of interesting names. Most people would gravitate to the Tehuantepec, which would be, again, what actually one of the professors in our department studied for one of her advanced degrees, was Tehuantepecers down off the Mexican coast. You can see funneled through a gap over the Gulf of Tehuantepec. So they did have a reason, I guess, for naming it that. But a number of interesting winds. You can see the hot wind at the bottom, temperatures in excess of 125 degrees with a dry, dusty wind. So interesting. I encourage you to take a gander, but again, do stress that this would not be a location that you should spend a lot of time studying. That's video 1 for this week. Hope all of you are well, stay healthy, and video 2 whenever you're ready. Take care.